Hey, new week. It's May finally. Well, it was May on Friday, but now we're really in May. So, starting off with the agenda, here is the agenda for this week. Now, if you notice, I'm doing 3 days of the same type of lesson because if you haven't noticed already, hello, welcome, good morning. We're in quadratics, and it's a little bit tricky to keep up with, especially distance learning. So I really need you to focus and pay attention on how to do these things. So we're gonna take it slow this week and talk about transformations, talk about vertex form, and then we're gonna finally get into solving quadratics on Thursday and Friday. So not a lot due this week. Friday progress report grades are due. I will have your quizzes, Unit 7 test, and prep works updated by Friday for sure. But as far as the grades go, make sure you're checking your grades, make sure you're missing or you're completing any missing assignments. Let me know if you turn something in so I can check on it for you. All right, so today we're going to be doing the packet. Today's probably going to be a long video. All I want you to do is follow along, fill in your packet, make sure you're comfortable with vertex form and how we get to transformations. No assignment due. Tomorrow, though, I will set up your Math Excel for you so you can get a head start on that, which is going to be due on Friday. I'm going to do some Kahoots. I'll assign you a Kahoot on Tuesday and Wednesday, and then that's that. So vertex form is another form of a quadratic equation. We already learned and talked about standard form and how to grab the vertex out. But vertex form is another way that's very easy. Oh, sorry. It's very easy to find the vertex from it because here's our equation. So in this equation, we have an x, and that x stays x, but now we have an h and a k and an a. So basically, hk is going to be your vertex, and the axis of symmetry is going to be whatever h is. Now, you know, in math and in our class, there's some things that are counterintuitive. So if you think that something is, oh, minus h is going to be negative, well, no, not in this case. This is the formula. So minus is a part of the formula, and then h is positive. But think of it this way. If you had x minus negative h, what would that become? That will become x plus h. So that means when you see a plus, this is why I wrote these notes over here. When you see a plus, the h value is negative. And when you see a minus, the h value is positive. Okay? So hk is your vertex, h is going to be the x value, and k is going to be the y value of your vertex. And then the axis of symmetry is what we found before. Remember, negative b over 2a, that is going to be whatever your h value is. All right, so let's get into this. I burned my hand last week, like in the oven, and now it's like kind of a scar and it's scabbing and now it hurts. Oh, it's itchy. Anyway, that was disgusting. I'm sorry. Oh, by the way, A kind of tells you what your if it's negative, it's opening down. If it's positive, it's opening up. And then we'll talk more about A later as it relates to transformations. So right now in these 4 problems, all we're going to do is talk about how to pick out the axis and the vertex. So in this case, H is going to be, remember, if it's plus, that means your H value is negative. And if it's minus, that means it's positive. So in this case, in number 1, our h is negative, and look at k. K is this constant over here, plus or minus, and that one's what you think it is. So if it's plus, it's positive, and this is going to be k equals, in our case, negative 2. So if our vertex is hk, that means we're going to have a vertex of negative 4, negative 2. Our axis of symmetry, since it's h, x is going to be equal to negative 4. Number 2, we have h is equal to positive 3 because it's minus. And then we have k, well, there's no k, so we can say that it's 0. So if our axis of symmetry is where h is, that means x is equal to 3, and our vertex is 3, 0. Again, this is in alphabetical order too, h, I, j, k, so h comes before k in your vertex. Okay. Number 3, so h equals 5, k equals negative 4. Since our axis of symmetry is whatever h is, x is equal to 5, and our vertex is 5, negative 4. All of the number 1 and number 3 have opened up. Number 2 has opened down, and number 4 is also going to open down. Okay, so let's take a look at this one. So this one is not in vertex form. However, we remember from standard form, A is -2, B in this case is 0, and C is 3. We don't really need C, but C is 3. So vertex form, where the axis of symmetry is -b over 2a, so 0 over anything, doesn't matter what it is going to be 0. And then we know the x value of our vertex is going to be 0. Plug in 0, and you get 3 as your y value. So this one wasn't necessarily in vertex form. We just had to remember our -b over 2a from our first lesson. I'm trying to grab it for you. From our first lesson here. So remember, if you had a problem like this, you would bring up -b over 2a. You get that, that's your x value, which is your x value of your vertex, and then we would plug in -4 to get our y. And in our case, in this problem, it was very easy to figure out that if you plugged in 0, you'd be left with a +3. Okay, so let's do everyone's favorite thing now. Let's start graphing using vertex form. And we want to place our vertex in the middle of the table. Good news for you is you probably will not be asked to graph using, a table a lot of the time. All right, so this is just basically to make sure you know how to plot. And if you're ever stuck, a table is always like a fallback, a fallback plan. So if you're ever stuck and trying to graph or solve to get a y value, you can always make a table, because plugging in x's to get y's will be forever a good skill. All right, so let's take out the vertex, and we're going to put it in the middle. So h in our case is -2. K is going to be equal to 7. So -2, 7. Notice I started with the vertex, and then we're going to fill in from there. So the axis of symmetry has to be -2, and then we're going to fill this in. So we're going to go to the left and to the right. Remember, in a parabola, these two values are the same and these two values are the same if you have them equal distant from the vertex. So -1 and -3 are both 1 away from the vertex. -4 and 0 are both 2 away from the vertex. So that's why they're able to be the same. Now, if I put 10 here, or -10, and I put 50 here, obviously those wouldn't be the same. So that's just something to think about. Now, if I'm going to plug in 0, obviously that's the easiest thing to plug in. So where is it? Let's see. Let's just plug in 0. So y is equal to -2 squared plus 7. So 2 squared is 4. -4 plus 7 equals 3. So if I plug in 0, I get 3, which means this will also be 3. Okay, if I plug in -1, y equals negative. -1 plus 2 is 1. Squared plus 7 equals -1 plus 7, which would be 6. Okay, again, nothing too crazy, just putting in points. So you're doing the same thing, except it's in a different form. But still, you're plugging something in and you're getting another value. Let's start by plotting our vertex. -2, 2, 3, 4, 5, 6, 7. This graph is opening down because of this negative a. So let's go -1, 6, -1, and then since this was 7, this is going to be 6. And that means I know that this over here is also going to be at y equals 6. Then we're going to go 0, 1, 2, 3. And I know that 1, 2, 1, 2 is also going to be at 3. Because remember, if I asked you to graph your axis of symmetry, which MathXL will ask you in a question to graph your axis of symmetry, you need to know to place a dashed line or a dashed vertical line at the x value where your vertex is. Yeah, you can't really see that, but it's a dashed line there, and then your parabola will obviously be solid. Okay, there's your graph, domain more often than not, all real numbers. And then your range. Your range will always be greater than or less than your y value of your vertex. Since this parabola is opening down, this is going to be less than or equal to. So y is going to be less than or equal to that 7. Let's do number 6. And we're not going to be really, this is the last one we're going to do just plain graphing without any other reason. So we're going to talk about transformations next. So this one, we've got no k. This one's going to be 0 for k. So h is going to be equal to 1. K is 0. So 1, 0, axis of symmetry is at x equals 1. Then we're going to go to the left. So to the left of 1 is 0 and then -1, and then to the right is 2 and 3. So let's plug in some stuff. Let's plug in, we can plug in 0, we can plug in 2, 3, whatever you want. So let's do 0 just because that's the best one to me. I don't know. So y is equal to 3 times, I plugged in 0 mentally, and 0 minus 1 is -1. So -1 squared is 1, and y equals 3 times 1, which is 3. So I just plugged in 0, and I got 3, which means I will get 3 here. And if I plug in 3, I'm going to get y equals 3 times, well, 3 minus 1 is 2, so 2 squared. So 3 minus 1 is 2, 2 squared is 4, y equals 3 times 4, which is 12. I don't even know if we can go up to 12 on this graph. Probably not. Let's just see how they did it over here. Oh, I just didn't do it. Okay, that's fine. Okay, so 1, 0 is our vertex. 1, 0, which is right here. It's opening up. And then we're going to do 0, 3. And then over on this side, 1 over, we're also going to do 0, 3. And then -1, 4, 5, 6, 7, 8, 9, 10, 11. We can say it's going to be up here. And so is this one. Just do our best here, right? Okay, so can anyone guess why this one was so narrow and so much distance between this point and this next point, and this one was kind of like regular? It's kind of, oh, well, it all fits here and blah, blah, blah. Real quick, let's do the domain and the range. Remember, this is opening up, so it's going to be greater than or equal to that y value, which is 0. Axis of symmetry would be right here. If you were to graph that, dashed line, there. Okay, so now we're going to talk about why these graphs move where they move and how they stretch, why they stretch, and what numbers would give you those pieces of information. So let's fill in this top part up here. So a transformation from a parent function. Remember, a parent function is like the most simplistic form of a graph. So the parent function of a quadratic is just y equals x squared. The parent function of a linear is just y equals x. And that's the most simple form of that graph. A transformation, oh, I'm sorry, I keep yawning. The transformation is known as a change to the size or position of that graph, okay? So in each of these problems that follow, what's there for you already is the parent function. So this is the parent graph, and we have to graph the other one, and I'm going to do it in a different color, hopefully I don't make a mistake, is going to be the actual graph, and we're going to describe what happens to it. We're going to describe how it changes. So let's do this one. We know that h is going to be -2 because this is +2 in here. So this is -2, and then there's no k. So it's -2, 0. We're going to just plug in other things. So we went to the left, -3, -4, -1, and 0. So if we plug in 0, it's going to be 2 squared, which is 4, which means this is also 4. If we plug in -1, -1 plus 2 is 1. 1 squared is 1. So let's graph this, right? Negative 1, negative 1, 1, 1 squared, 1. Okay. So negative 2, 0, negative 1, 2, 0 is right here. I have negative 3, 1. That means I'm going to have negative 1, 1, and 0, 4. Kids, you should not be graphing in pen. Please don't graph in pen. Okay, so here's our graph. And let's compare how it changed from our parent function. So let's look at the vertex first. Let's compare. Always want to start by comparing the vertex. Start by comparing the vertex. So where did this vertex go? Well, the new one that we just did moved 1, 2 spaces left. And is that it? Did it get any wider? Did it move up, down? Did it compress? Did it stretch? No. It just kind of moved 2 spaces to the left, and that was it. All right, let's look at number 8. So number 8, number 8 has no B. So if we were to look at this one, B would be, it's not in vertex form. So B would technically be 0. A equals 1, B equals 0. So remember, negative B over 2A tells us that 0 over anything would give us 0. We plug 0 in, we get 5. So 0, 5 is our new vertex. Okay, let's put points. Remember, these two and these two are going to be the same. So let's plug in 1. We get 1 squared is 1. 1 plus 5 is 6. That means this is also 6. We plug in 2. We get 2 squared is 4. 4 plus 5 is 9. Quick mental math. I really didn't need this space over here. So this would have been negative 0 over 2 times 1, which is 0. Okay, this one was a lot of mental math, figuring out the table. Okay, if you need to run that back and listen to what I was saying, all you're doing is plugging in the x's to get the correct y. All right, let's graph this. So let's start with our vertex, 0, 5. So 1, 2, 3, 4, 5. Negative 1, 6. And that means that 1 is also 6 over here. And then we've got 2, 9. Let's just say it's right here. And let's just say this one is also right here. Okay, so again, what happened to this graph? Here was the vertex before, now where is the vertex? The only thing that happened is it went up how many spaces? If you're saying 5, oh duh, because it's right here, then you're correct. So all this graph did, it went up 5. That's it. So it was a shift. Shift up 5. This one was shift 2 left. Okay, let's look at number 9. If we can practice vertex form by seeing it, I see that this number right here is going to be my x value, which is going to be negative 1. This is going to be my y value, which is negative 6. Now we start filling in this table. So 2 to the left, negative 2, negative 3. This is 0 and 1. These are going to be the same, and these are going to be the same because I picked these numbers on purpose. So let's plug in 1. Let's plug in 1. 1 plus 1 is 2. 2 squared is 4. 4 minus 6 is negative 2. Let's plug in 0. 0 plus 1 is 1. 1 squared is 1. 1 minus 6 is negative 5. Again, mental math to fill in the table. If you need us to, go over any of these, we can do y equals 1 plus 1 squared minus 6, which gives us 2 squared minus 6, which gives us 4 minus 6, which equals negative 2. That's how we got this value. That's just if you needed to go over it. If you didn't, then great. So negative 1 negative 1, 2, 3, 4, 5, 6. 0, negative 5 would be here, which means that this point is also over here. And then 1, negative 2, which means 1, 2, 1, 2. Okay. So even though my graphs look smaller than the original one, they're not. They're the same exact one, and I think this one was the best one. They're the same exact width, they're the same exact everything. It's just, obviously this is a computer drawing it, not drawing it. So clearly I'm better than a computer, but I'm just kidding. So this one went vertex. Remember, we're comparing vertex to vertex. So from the parent one, what happened? So this one is definitely shifting. So it shifted down how many? 1, 2, 3, 4, 5, 6. So it shifted down 6, but it didn't stop here. It also shifted 1 left. So those are 2 transformations in here. And then let's talk about this last one. No, we've got 2 more. Let's talk about this one. So vertex form tells us that our x value is 4, 1. Because if this is minus 4, that 4 is going to be positive in our vertex. So let's fill in to the left. Have I been doing this right? Yeah. 3, 2, 5, 6. Sorry, I always question myself when I'm doing math on camera. Okay. So these are going to be the same. These are going to be the same. I'm so tired of saying that, but you get the point. So if we plug in a 5, mental math, 5 minus 4 is 1. 1 squared is 1. I know there's going to be someone struggling, so this becomes negative 1 plus 1, which equals 0. Right? If I plug in 5, go through this. This is 1, however, this negative comes down, so it's negative 1 plus 1, which is 0. Okay, let's plug in 6. We can do mental math. 6 minus 4 is 2. 2 squared is 4. Negative 4 plus 1 is negative 3. Okay. 4, 1. 1, 2, 3, 4, 1. 3, 0. And 5, 0. And then 6, negative 3. That means that this one is also negative 3. Okay, what happened to this one? So all of the other ones have been opening in the same direction, but this one now is not. So this is called a reflection. So first it moved, let's do the shifts first. It shifted, the vertex went up 1. It shifted to the right, how many? 1, 2, 3, 4. And it also reflected. It reflected. So if this is negative, what you're going to find reflected over the x-axis. If this is negative, we're going to have a reflection in here. Okay. Let's go on to numbers 10 and 11. So number 11 says, well, there's no b, so we know it's going to be 0. If we plug in 0, we get negative 7 as our y value. So going to the left, going to the right, and if we plug in 1, we get 3 minus 7, which is negative 4. If we plug in 2, we get 4 times 3, which is 12. 12 minus 5, sorry, 12 minus 7 is 5. Is that right, guys? Before I start graphing this? I don't know, maybe you should work it out. Oh, touche, friends, touche. So 3 times 2 squared minus 7. 3 times 4 minus 7, which means 12 minus 7. Yes, that's right. Okay. Okay, good, good, good. 0, negative 7. 1, 2, 3. Okay, this one's opening up. So we've got 1, negative 4. So this is 7. 654. And then this one is 25. Oh man. 1, 2, 1, 2. The boxes trip me out sometimes. Just too many. All right, so what do we notice about this one? Now, I'm not just a bad drawer. This one is actually skinnier. So the first thing we can see is that this one is stretch, or we can say narrower. And what happened to the vertex? It moved, it was a shift down. We counted all the way down to -7. Hey, down 7. All right, now how's that? Last one. Then we're going to put all this together and see if there's an easier way to recognize transformations than just graphing, because clearly, who likes graphing? So vertex here would be 3, -2. And then we want to plug in 2, 1, 4, 5. So if we plug in, we're going to have a fraction. If we plug in 2, we're going to do this. -1/2 times 2 minus 3 squared minus 2. -1/2 times -1 squared minus 2. Oh, helpful if you could see it. -1/2 times 1 minus 2. So this becomes -1/2 minus 2, which we're really adding 1/2 to -2, or we're adding a half and 2 and making a negative. -2.5. Is that okay with you? It's okay with me. Right? Same signs. We know we're adding the numbers and keeping the sign. So that's that. Let's plug in 1. I should have did this, whatever. Let's plug in 1. So -1/2 times 1 minus 3 squared minus 2. -1/2 times -2 squared minus 2. -1/2 times 4 minus 2. -1/2 times 4 is going to give me -2 minus 2 equals -4. Okay. 3 -2, 1, 2, 3, -1, 2, 2, 2, -2.5. It's like halfway here. That was, ugh, I hate that. That's okay. And then 1, -4. So 1, -1, 2, 3, 4. All right, now, again, I'm not a bad drawer, but if you thought that this one looked a little wider, you are correct, because look how little the space was between these points. So this is compressed / wider. And what else is it? It's reflected over the x-axis, because it was opening up and now it's opening down. This vertex moved down 1, 2 spaces, so it was a shift. Handwriting is atrocious right now. Down 2, and then it also shifted to the right 1, 2, 3 spaces. So this one had the most transformations, but look at the equation. It had the most extra things done to it. It was a negative, it had a different number than 1 as A, it had an H, and it had a K. So that's why all those transformations happened to that graph. Well, friends, look at our little cheat sheet here. So let's put it all together, right? Let's make our lives a little bit easier. So if we're given a quadratic equation in vertex form, which for the most part, expected. So if you're given a quadratic equation in vertex form, H for horizontal is going to be your horizontal shift. So whatever in the parentheses, that means your graph is shifting left and right. And again, remember, plus as your H means it's going left or negative. If it's right, and your h is just minus h, that means you're shifting right or in a positive direction. That is going to be the most confusing thing for some of you. But with horizontal movement or inside the parentheses, whatever it says, it is the opposite. So if I think negative, I want to say left. However, I know that it's going to mean right because that means h is positive. My k, this number over here, your vertical shift, it's kind of like, I don't want to say your intercept because it's not your intercept, but it's just kind of the constant that tells you whether it's going up or down. All right, if a is negative, that means the function is reflected over the x-axis. So if it was opening up, now it's down. If it was opening down, now it's up. Or if a is negative, it's basically the opposite. So if you have something that's negative and is now positive, it reflected up. Okay, now between stretches and compressions. Okay, if a is greater than 1, the absolute value of a is greater than 1, that means it's a stretch. Basically, this means whole numbers greater than 1, clearly, right? We don't have any, like, if a is bigger than 1, we know it's going to be a narrower graph. So this one means, and this one means wider. So if a is between 0 and 1, aka a fraction, a proper fraction, like 1/2, 3/4, 2/3, whatever, that one's going to become a compression. Okay, so this means your graph's going to be wider. This means your graph is going to be narrower. So if we are going to be asked to read translations and read descriptions, we have to be able to write the equation, and we want to write an equation either in standard form or vertex form. Usually it's going to be in vertex form. So in number 13, we want something that's translated 2 units to the right. So we're always going to start with y equals, there's no a, so we don't need to worry about a, because there's no reflection, there's no narrow, there's no compression, there's no stretch. So it's just y equals parentheses. We know we're going to have an x, we know we're going to have a square. That's it. That's all we know for sure with this problem. So 2 units to the right, right means horizontal, so we're going to talk about h. So if it's going to the right, I know that it's going to be minus something, and then how many units? 2. Okay, nothing else. There's no adding because it's not up or down. It's just 2 units right means horizontal movement, which means that your h is moved, or is whatever. So a shift in a translation, obviously, not obviously, but a shift in a translation, FYI, mean the same exact thing. So translating just means, oh my gosh, I'm so sorry. Translating just means moving or shift. So again, if you're shifting 5 units up, this means that there is no reflection, there's no stretch or compression, and there's not even a horizontal movement. So you do not even need parentheses in this one. So it's basically x squared plus 5. So since there's no horizontal, don't need parentheses. Okay, you just need to make sure your x is squared, because look, your x would be squared over here if you actually square this binomial. Okay, nothing else except that shift up 5, and that's your k. So plus or minus at the very end. Number 15, now we've got 2 translations, or 2 transformations here. So we've got left and down, so we've got vertical and horizontal movement, which is the h and the k. So again, no a, no reflection, no stretch compression, so we can do y equals parentheses x, and since it's 3 units left, I'm going to look over here, left means plus, so I'm going to do x plus 3, don't forget your squared, and then 4 units down means minus 4. Okay, this again is right and up, so I don't need anything as my a. So 7 units right, right means minus, so I'm going to do minus 7 squared, and then 4 up means plus 4. All right, now next 17. I have a reflection and then a down. Reflection and down. So no horizontal. So does that mean I need parentheses? No, I do not need parentheses. So if it's reflected, I know it's going to be negative x squared. And then 3 down means minus 3. Promise, the more you do these, the better you will get. They seem really hard at first, but they're not. Okay, number 18, we have a reflection. We have 5 units right, 2 units down. So we've got a couple of things going on here. So since we have horizontal, we need our parentheses. Okay, and since we're going right, I know it's going to be minus. So it's minus 5. And 2 units down means minus 2 as your K. All right, now this one has a vertical compression by a factor of 1/3, then 8 units up. Again, no horizontal for this one or this one, so I do not need parentheses. There's no reflection, so this is not negative. However, A is now 1/3. Notice in any of these, I did not have a coefficient for my A because it doesn't tell me a factor of compression or stretching. So I didn't need one, but now it is, so I need that 1/3 as my A. And then it's going to be x squared, because clearly it's quadratic. And we have translated 8 units up. Up means K, so it's up. That makes sense. Up is plus 4. Okay, and this one is the big one. So it's stretched by a factor of 2 and reflected. So I know that this is y equals negative 2. Now, if I have horizontal movement, I need parentheses. If I don't, I just write x squared. So negative 2, oh, and we have 4 units left, so I do need parentheses. Left means the opposite of what you think. So plus, and then there's no up or down, and this would be our answer. I love doing this. I love transformations. They get better once you practice more, just like with anything I've ever told you. So that's that. Tomorrow we will be practicing homework 3, so I'll work out all the problems with you, and on Wednesday I will be doing some problems from your Math Excel assignment and from our old handy textbook to practice more transformations, you picking out graphs and everything. All right, well, I hope you have a good day. Please come to office hours if you want to practice more before tomorrow and Wednesday, and I hope to see you there. All right, bye.